Hello everyone and welcome once again to MJ's Maths and Stats. That's MJ Magic Studio to you. I'm your host, your host, and as usual in the host mode, Mohit Jain. Today in this masterclass, we would be discussing odd nuances of how to generate or how to find second last digit or last two digits of any expression. So we have different models which we would be going through, and before this, please go through that unit digit masterclass. I think I am still to produce that. I need to check. And reminders. That's it. That would be of great help. So let's don't waste our time. Subscribe to the channel. And let's start. So second last digit is actually the 10th place digit in any expression. We have an expression, number, unit place, 10th place. Second last digit is 10th place, or last two digit we need to calculate these two values for any expression. And to start with, we are starting with the remainder logic. And what does this logic says? That the last two digits of any expression are the remainder obtained when the expression is divided by 100. Isn't it? Suppose we have a number 343. If I ask you that what are the last two digits of 343, you will say 43. Clear? Now can I say that 43 is nothing but the remainder obtained when 343 is actually divided by 100? If I divide 343 by 100, I will get remainder 43. So what are the last two digits of any expression? Last two digits of any expression are the remainder obtained when the expression is divided by 100. We can use this as the first logic to start solving and identifying the last two digits. And if remainder is 0, you can ask, what if remainder is 0? If remainder is 0, then last two digits of that expression are nothing but 0, 0. That's why remainder is 0. And one more thing, for working purposes, we can use factors of 100 also. Factors of 100, like easy factors, are 10, 20, 25, 50, or 100 itself. We can divide the expression by these numbers and we can find the remainder. If we are dividing by 10, whatever remainder we will get, we will multiply it by 10. Then that will give us the last two digits. If we are dividing by 20, whatever remainder we will get, we will multiply this expression by 5, then we will get the last two digits. Let's see with this particular remainder logic with few examples. Let's take this example. We need to find the last two digits of 15 into 37 into 63 into 51 into 97 into 70. So as far as logic goes, let's divide this by 100. Now we can see that one of the number is multiple of 5. So this will become 3 divided by 5 and this will become 20. Now we need to just identify the remainders of different parts when divided by 20. When 3 is divided by 20, remainder is 3. When 37 is divided by 20, you can say that remainder is 17. But since 17 is a large number, we can very easily say that remainder is minus 3, which is nothing but the residue. If 3 is added to 17, it becomes 20. 17 is the surplus, 3 is the deficit. We can also use the deficit remainders. When 37 is divided by 20, deficit remainder is minus 3. Now 63 by 20, remainder is 3. 51 by 20, we can say remainder is 11 or minus 9. 97 by 20, remainder is 17 or minus 3. And 17 by 20, remainder is 17 or minus 3. Now our task is to multiply all these remainder. So final remainder would be 3 into minus 3 into 3 into minus 9 into minus 3 into minus 3, and we do know that this number on multiplication would be greater than 20. So let's multiply this again in parts and again divide it by 20. So minus 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 4 times, it will give a positive result. This is 27 and this is 9 into 9, 81. I'm again dividing this by 20. 27 by 20 will give remainder 7 and 81 by 20 will give remainder 1. So final remainder when divided by 20 is 7. But mind you, we are dividing this by 20. As said, if we are dividing by 20, we need to multiply this by 5, since we have divided these two numbers by 5. So 7 into 5 will give 35, and 35 is nothing but last two digits of this expression when multiplied. So if I use calculator also with use of calculator, this number is actually equals to 29405 and you can see the last two digit of this expression is 35. So why to actually use calculator or multiplier to find the last two digits? Let's do one more on the same line. The same kind of question is on your screen. Pause and try to solve it. So let's use the same process. Divide this by 100 and let's see if we can reduce this. 5, this will go 13, this will become 20, 2, 10 and this will become 31. 13 by 10, remainder is 3. 29 by 10, remainder will be 9 or minus 1. Then 37 by 10, remainder is 7 or minus 3. 63 by 10, remainder is 3. 71 by 10, remainder is 1. 87 by 10, remainder is 7 or minus 3. 31 by 10, remainder is 1. So we have minus 1, 2, 3, 27, 3, 81, minus 81. Now again this divided by 10 will leave remainder minus of 1. Now we cannot have negative remainder, we will add the divisor to it. Divisor in this case is 10. When we are adding divisor to it, it becomes 9. So when this expression is divided by 10, remainder is 9. But we need to see that since it is divided by 10, we need to multiply this back by 10. So 9 into 10 will be 90 and these are the last two digits of this expression given. Do practice these kind of questions with the remainder logic. Moving on to the second process, that is manual computation of cycle. Manually, if you can calculate. For few numbers we can try, but not for all numbers we can do this manual computation. Like for few easy numbers, let's do. Let me try to identify cycle for powers of 15. 15 to the power 1, last two digits are 15. 15 is square 225, so last two digits will be 25. Now 15 cube last two digit, we just need to multiply 25 by 15. 15, 5, 5, 7, 10, 75. Last two digit what we will get is 75. Again let us multiply this by 15. 15, 5, 75, 7, 100, 5, 7, 2. Again we will get 2, 5. So now here you can see that as we are moving on, we are getting a repetition of 25, 75, 25, 75, again 25, 75. This is what I mean by manual computation of cycle. Manually, if you can remember these for a specific number, then it is very fine. If you can't, you can try this out. Keep on multiplying a number repetitively and finding the last two digits of the power and stop where you get the repetition. Here in case of 15, what we can see that for 15 to the power x is all depend upon x. If x is even, that is power is even, last two digits of the expression are 25, and if x is odd, then last two digits of the entire expression are 75. Here you can see for 2 it is 25, when power 4 it is 25, again for power 6 it will be 25 and on. So if somebody asks you that find last two digit of 32415 to the power 414. So what you will see that last two digits of this number are 15 and power is even. So this becomes 15 to the power even. 15 to the power even, last two digits are 2525. Let's take one more example. Let me identify for 07. 07 to the power 1 will give 07. Then into 7 square 7 7 49. 07 to the power 3 49. 7 3 43. Then power 4 into 7 21 2. And 7 28 30 01. And 07 to the power 5 will be again 07. Bingo. Here we can see that this follows cycle of 4. That means after every 4 powers, again the last two digits repeat itself. Clear? So what will be the algorithm for a number whose last two digits are 7 and we need to identify the last two digits of the expression? Let me take an example. If somebody asks what are the last two digits of 4607 to the power 3575. Now we see that last two digit of this number is 07 and this follows the cyclicity of 4. That means it's simple. Divide the last two digits of the power by 4 and find the remainder. So when 75 is divided by 4, 72, remainder is 3. So remainder is 3 means we are looking out for third power of 7, we will get 43. That means last two digit of 4607 to the power 3575 is 4343. Just one more. 607 to the power 3526. 26 divided by 4. Remainder 2. If remainder is 2, we are looking out for 7 to the power 2. Last two digits are 49. For this, last two digits are 4949. To dwell more deeper into concept of cyclicity, please go through the unit digit masterclass. Link is there in the description. Find last two digits of 36 to the power 726. Now here we need to identify the cycle for 36. Let's see, can we identify that? 36 to the power 1, last two digits are 36. 36 whole square will give 96. Then whole cube will give 56. To the power 4 will give 16. To the power 5 will give 76. To the power 6 will give 36. Stop. As soon we are getting 36, we can stop. Here we can see that this follows cycle of 5. That means what? Power 726 need to be divided by 5 and we need to find the remainder. When 726 is divided by 5, remainder is 1. If remainder is 1, it is nothing but last two digits of 36 to the power 1. So last two digits of 36 to the power 726 would be actually last two digits of 36 to the power 1, that is equals to 36. Suppose this power is 725. 725 means remainder is 0. In case remainder is 0, we will always go for power 5. That means last two digits of 36 to the power 725 is nothing but last two digits of 36 to the power 5. After 5 only this power 1 will come. Na? After 5 only this 6 will come, which eventually becomes 1. So last two digits of 36 to the power 5 is 76. So last two digits of 36 to the power 725 or any power where remainder is 0, we would be looking out for power 5. Or else whatever remainder you get, you just check out that. If remainder is 2, go for 36 to the power 2 and on. So summarization on manual computation of cycle, you can use it manually, you can find it, and the fact with computation of cycle is last two digits of any number will repeat after every 20 powers. After every 20 cycle, कोई भी number उठा लाइए, after every 20 powers, its last two digit will repeat. But the question here is after every 20 powers, this is true for all two digits number. From 01 to 99 to the power 20, 21th power is nothing but the same last two digit again. That means 07 to the power 1 is same as 07 to the power 21 and on. 56 to the power 1, that is 56, is same as 56 to the power 21 and 1. Clear? If you can't understand any other process, you can identify all the powers till 20. But it is a tedious task, isn't it? If I only try to do with 3 only, it will take so much time. That's why we have got some other processes also. But this is Ramban. This is simply the fact which we should know, that we can divide powers by 20 and we can adjust if we know. As simple as that. Last two digits of any number will repeat after every 20 powers. We can check for 3 even, like 03, then 09, 27, 81 into 3, 43, 92, 29, 87 into 3 will give 61, into 3, 38, 83, into 3, 9 and 4, 49, into 3, 7, 47, into 3 will be 41, 3, 2, 23, 6, 9, then it will be 07, then 3, 21, then 6, 3, then 8, 9, then 6, 7, into 3, 0, 1, bingo. After this, again we will get 03. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. See. And this is the fact with any two-digit number power. Last two digits of any number will repeat after every 20 powers. But manually generating this for any number whatsoever is a tedious task, and that's why we have part 3 format based few numbers, positions whose last digit we can learn and find it in no time. Let's start the third part of this second last digit masterclass, and this is on format based. We will pick up few different kind of numbers, and then we will see how to calculate the last two digits. So I have taken up any number which ends with 1 and to the power n. Clear? Now whatever be the number, please break this number as A1, and we need last digit of the power, that is n. What we need is second last digit of the number A, and we need last digit of the power n, let that be t. Then last digit of this entire number is nothing but last digit of A multiplied by t, and after that just put a 1. Let me show it to you. We have a number 6631 to the power 67. What is the value of A here? 3. And what is the value of t? 7. Now 3 into 7 is 21. Last digit of 21 is 1. And then we just need to put 1 more. These are the last two digits of 6631 to the power 67. 7771 to the power 777. Again, we can see that last digit of number is 1. Bingo. Identify your A, that is 7. Identify your T, that is 7. Now 7 into 7 is how much? 49. So we just need last digit of 49, that is 9, and put 1 after it. These are last two digits of 7771 to the power 777. As simple as that. Let's do few more. 41 to the power 23. 4 into 3 is 12. 2 and then 1. Last two digit is 2121. Let's take one more. 141 to the power 22. 4. 4 into 2 is 8 and just put 1. Just do one more. 701 to the power 459. So 0 into 9 will give 0 as last digit and then 1. So last two digit of 701 to the power 459 is 01. And last one more, 871 to the power 123. Just keep on practicing. Take up a number from your end. Just put raise any power and keep on doing. 7 into 3, 21 and then put a 1. So last two digits are 1, 1, 11. So this is the very intelligent format for any number which ends with 1. How to find the last two digits. And many time our target is to convert whatever number is given to us in the form so that we can get 1 at the end. If we can get 1 at the end, then very easily we can find the last two digits. Now the next one is any number ending with 5 raised to the power n. We want to find the last two digits of that. And here we need to remember two things. Number one, first, last two digit of any number where second last digit is odd and last digit is 5 raised to the power odd, last two digits are always 75. Just keep this in mind. We have any number where second last digit is an odd digit, last digit is 5 and power is odd, then last two digit of the entire expression will be always 75. And second thing is otherwise for any number ending with 5 power n, the last two digits are always 25. That's it. This is for number ending with 5. Make a note of few examples. 65 to the power 125. This is even. Forget it. The last two digit will be 25. As simple as that. First, if second last digit is odd, then only check whether the power is odd or even. If second last digit is even, straight away you can write that last two digit of this entire expression has to be 2525. 75 to the power 24. Second last digit is odd. Bingo. Now go and check the power. Power is even. Forget it. Last two digit is 25. We will not go into 75 model, isn't it? Now 75 to the power, let's take 27. Second last digit is odd. Now go to the power. Power is also odd. Odd matching. The last two digit of this expression when solved would be 7575. 78315 raised to the power 33315. And they are asking for last two digits. Second last digit or last two digit. We see that last digit is 5. Second last digit is odd. Bingo. Go to the power. Power is odd. Bingo. We know that last two digit would be 75 and nothing else. Next we will look out for last two digits of 3 to the power k. Now whenever we have this 3 as the last digit of any number, try to convert this k in the form of 4n plus minus r format. Now why? Because 3 to the power 4 is 8181. And if we get 81, we can go back to our format of last digit is 1 raised to any power of n. Like if we are looking out for last digit of 3 to the power 80, last two digits basically, we can write this as 3 to the power 4 raised to the power 20. Now 3 to the power 4 is 81, we know that. Now, what are the last two digits of 81 to the power 20? Simply 8 into 0, that is 0, and just put a 1. We have just seen in format number 1. Try for 3 to the power 998 and tell me what would be the last two digits of this expression. We need to convert our power in the format of 4n plus minus r. Divide the entire number by 4, or simply just write 3 to the power 4 and divide this by 4 and see how many times, how many cycles we can get. 2 cycles, then 18, 4 cycles, 16, 28, no, 18, 19, 19, 30, 38, 9 cycles. We are left with 2 cycles. So this is nothing but 3 to the power 4 to the power 249 into 3 square. That is, this is 81 to the power 249 into 9. Now we can very easily find the last two digits of this. This will be 8 into 9. 8 into 9 is 72. Last digit of 72 is 2, and just put 1. Now 21 into 9 will give us what? 9 into 1 is 9. 9 2 is 18, that is 8. So last two digits of 3 to the power 998 is nothing but 8989. Next we have 7 to the power k. Again, here also we'll maintain the format of 4n plus minus r. Why? Because last two digits of 7 to the power 4 are 0, 1. We have seen in cyclicity of 7 earlier. For example, looking out for last two digits of 7 to the power 64, it is simply 7 to the power 4 raised to the power 16. That means 7 to the power 4 last two digit is 0, 1. And now we know the drill. 0 into 6 will give 0 and then put a 1. Isn't it? Okay, let's try with one more number. 7 to the power 1836. Give it a try. So I know that I need to go for 7 to the power 4 groups. 4, 16, 23 would be 5, 36 is 9. Confirmed. Again 0, 1 to the power 4, 5, 9. 0 into 9. 0 into 9 is 0 and then again 1. Bingo. Again one more. 7 to the power 353. Pause and give it a try. 7 to the power 4, let me divide. It will go how many? 8 and then 8 and we are left with 7 to the power 1. So last digit of this we know would be 0, 1 to the power anything will give 0, 1 into 7. So last two digits of this entire expression is 0, 7. Very good. Now people would have understood that how we can generate formats for these. Like if I need to generate formats for 9 to the power k, the very best power of 9 which can give me the last digit 1 is 9 square 81. So last two digit of 9 square is 81. So I'll try to convert my k into 2n plus minus r. As simple as that. Let's check some example. 9 to the power 4032. We are looking out for last two digit. So this will be 9 to the power 2 to the power 2016. So this will be last two digit of 9 square 81 to the power 2016. 8 into 6 is 48. Last digit is 8 and then 1. So last digit of 9 to the power 4032 is 8181. Isn't it? So you people give it a try. Try this 9 to the power 5267. Pause it and tell me what can be the last two digit of this expression. Okay, I hope you must have the answer by now. Let's see. So it is 9 to the power 2. This will be 2 2633, and we are left with remainder 1, 9 to the power 1. So this portion let's solve. This would be 81 to the power 2633. We know the rule, 8 into 3 is 24. So we'll get 4 and then a 1. So last two digit of first expression is 41 and second expression 9 to the power 1 is 9. Just need to multiply. 9 into 4, 36. So last two digit is 6969. Now there is an interesting logic which we should understand so that we can use whatever we have learned in format based, last digit ending with 1 to the power n, 5 to the power n, 3 to the power k, 7 to the power k, 9 to the power k. And what is this? That numbers of the form x square, 50 minus x square, or 50 plus x square, and 100 minus x square, all second last digit, all last two digit is same as last two digit of x square. And this is a very interesting fact. We can take an example. 13 square is 169. Last two digits 69. Now 50 minus 13 if I take is 37, and 37 square is 1369. Last two digit is 69. 50 plus 13 if I take, that would be 63. 63 square is 3969. Last two digit is 69. And one more, 100 minus 13, that is 87. 87 square is 7569. Last two digits are also 69. We can use this in solving variety of problems. Let's quickly run one more check for 19, because these two are very favorite, exam favorite numbers. Like 19 square, 361. 50 minus 19 is 31. 31 square is 961. 50 plus 19 is 69. 69 square is 4761. And 100 minus 19 would be 81. 81 square is 6561. Okay, let's try to do this with some example. We need to find last two digits of 37 to the power 64. Now, we know 37 is 1369. 37 is square. We know last two digits of 37 is square, that is 69. But this is 37 to the power 64. So let's break up. And again it is 69. 69 will come somewhere. Why I have taken up example of 13 and 19 is because of this link. See the wonderful link. We try to get to this number 69, and then if we get this number 69, very next step would be to convert 69 squares so that we can get a number which ends with 1. And we know how to find the last two digits of a number which ends with 1 to the power n. That is why we learn these things, 13, 19, it gives us the link to 1. So 37 is square and will end with 69. We can get through here. 69 is square is 61. So can I write this as 37 square into 37 square? This is raised to the power 4, and then it would be overall raised to the power 60. 37 square ends with 69, last two digit. 37 square ends with 69, and then 69 square will end with 61. That means last two digit of 37 square into 37 square is 6161. So last two digit of the entire expression is 61 to the power 16. Now we know the pattern. 6 into 6 will give 6 and then a 1. Last two digit of 37 to the power 64 is 6161. Okay, let's take up one more example. Last two digits of 133 to the power 128. Now last two digit of 133 is 33. 33. Yes, 33 is square is last two digit is same as 17 is square. 17 is square, last two digit is 89. So first we need to break this number as 33 square into 33 square raised to the power 432. Now last two digit of 33 square is 89. Last two digit of 33 square is 89. We are looking out for last two digits of 89 square. 89 square is relatable with 100. 100 minus 89 is 11. 11 square, last two digit is 21. That means last two digit of 89 into 89 is 21. That means we are looking out for last two digit of 21 to the power 32. Bingo. As soon as we get 1, our target is to bring that, boil down the number so that we get last two digits. Last digit has 1. Then we know the process. 2 into 2 is 4 and then put a 1. So last digit of 133 to the power 128 is 4141. Hence, towards the end of the concepts on second last digit is 2 to the power k. And here, the pattern which it will be following is last two digits of 2 to the power 10 is 2424. And we need to work on this logic. First of all, last two digits of 2 to the power 10 is 24. And the beautiful thing is 24 to any power shows a specific pattern. Last two digits of 24 to any even power is always 7676. And last two digit of 24 raised to any odd power is 2424. They follow the cyclicity of odd even powers. So if any even endings are there which can be converted into the last two digit 24, then we can follow the rule of simple 24 to the power even power will always end with 76 and 24 to odd power will always end with 2424. Let's see few example. And one more here important thing is, which might be of some help, that if you end up getting any number of the form, that you need to find last two digit of 76 into 2 to the power k. Clear? That is nothing but last two digits of 2 to the power k, where k is a small number in that case. Try to convert your big numbers into this format, 76 into 2k. So if you get any number of the form where you need to find last two digits of 76 into 2 to the power k, this is nothing but last two digits of 2 to the power k, because last two digits of 76 to the power n are always 76. Last two digits of 76 raised to any power is always 76. With this help, we can very easily find last two digits of even endings, or where we can take it to 24. We will solve few of them. Let's start with the first one. We are looking out for last two digits of 2 to the power 70. Catch 2 to the power 10 we need. We are looking out for last two digits of 2 to the power 10 raised to the power 57. Last two digits of 2 to the power 10 is 24. And the power now is odd. So it fits in here. Last two digits of 22 raised to any odd power is always 24. I missound as 22, but it is 24. 24 raised to the power odd, last two digit will be always 24. So let's find last two digit of 4 to the power 508. Pause and give it a try. So let's check. This is 2 to the power 1016. and we know we need to convert this into 2 to the power 10. Let's divide this by 10. It will be 101 time, and remainder would be 6 into 2 to the power 6. 2 to the power 10, last two digits are 24. 24 raised to the power 101 into 2 to the power 6. Now 24 raised to the power odd. 24 raised to the power odd with end with 24. And 2 to the power 6 is 64. So 24 into 64, 4, 4, 16, 1 and 8 and 1, 9, 9 and 4 is 3. Last two digit of this entire expression would be 3636. Let's try this. 2 to the power 998. Last two digits. So 2 to the power 10 we require 998 9 times into 2 to the power 8. Now 2 to the power 10 is 24. Last two digit 24 raised to the power odd will end with 24 into 2 to the power 8 is 256. So into 56 we need to do. Clear. So it is simply 4, 6 is 4, 2, 24, 56, 24, 2, 12, 14 and 24. So last two digit what we'll get is 4, 4, 44. Can do it simply. Let's try one more. 2 to the power 87. Let's do it. 2 to the power 10 raised to the power 8 into 2 to the power 7. Now 2 to the power 10 is 24 raised to the power even. And 24 raised to the power even will end up in last two digits 76. So we are getting 76 into 2 to the power 7. Now we know that one more thing, that last two digits of 76 into 2 to the power k is simply last two digits of 2 to the power 7. 2 to the power 7 last two digit is 2828. Now in the end I want to summarize something which would be of great help for good big powers. We know that last two digit of any number will repeat after 20 powers. We know that. Now if last digit is even, I'm talking about last digit, or we have an even number and it is raised to the power 20k, its last two digits will be always 76, except in case of 0 raised to the power 20k will always end with 00. So these are the very important notes for big numbers. We can use this. If power is in the form of 20k and we have an even number not ending with 0 but ending with either 2, 4, 6 or 8 and power is in the form of 20k, last two digit will be always 76. We can prove this with the notes which we have done till now. Now, if we have an odd number or last digit is an odd, then raised to the power 20k, last two digits are always 01, except if last digit is 5, raised to the power 20k, last two digit would be 2525, the very important last second notes for long run questions. In if power is divisible by 20. So on this note, do try to give me the answer for that. What is the sum of last two digits of the expression 1 to the power 99 plus 4 to the power 96 plus 2 to the power 98 plus 3 to the power 97 whole raised to the power 100 100? Do let us know in the comment box. Thank you everyone for participating. This is Mohit Jain signing off from MJ's Maths and Stats. That's MJ Magic Studio to you. Do go through the unit digit and all the master classes of number system. Links are there in the description. Do follow it. Subscribe to the channel and stay well. I'll see you soon.